the depth of the problems or the experience that you will get when you go through a formal degree such as a bachelor's degree in data science or a master's degree in data science, and of course a PhD is for a more research oriented. Of course a PhD goes a long way even in academics, but this is not to say that if you don't have one of these degrees you cannot get into this domain. But I just wanted to give you an idea of the kind of profiles that are there in these in this industry as of today. Okay, so PhD is also a very valued, and it is something that you could think about. People who have already completed your masters and you want to continue in this field in academics, that is an option you could look at. One of the most exciting things about data science for me personally is that it is domain agnostic. What I mean by that is that you can pick any domain that you like, ranging from health sciences, life sciences, to sports, to finance, to HR, and data science will have a role to play in it. And so it is one of the most fascinating things about data science. So if you loved, say for example, you loved sport, okay, and you didn't get a chance to pursue sports as a profession, you could take up data science and win sports analytics as a field is a much upcoming field today. So this is also a point relevant to the fact that data science is full of opportunities. So you don't have to restrict yourself to any particular domain. Almost every domain that you can think of today will have a data science aspect to it. Okay. The next thing that I wanted to talk about is the toolkit. Okay, what do you have? What do data science professionals? What are the skills that they generally have? And probably, like most of you would have guessed by now, I think almost 75% of data science professionals use Python today, and I think RStudio comes a close second. So Python has been, one of the most popular programming languages used by data scientists. So if you are looking to start in this field, this is definitely something that you have to get used to. Regarding other, mostly open source tools are most preferred by data science professionals. So though there may be many proprietary tools available, these days the world's moving towards open source tools, which is good in a way because there is so much help available with open source tools. There is a vibrant community of users, and this makes it very easy for people who are starting out in the field to adopt and to learn these tools. Okay, so these are all statistics from the latest report. I want to give it just a little bit of idea about what are the kind of problems or what are the kind of fields that are being worked on today. So again, this is something that you may have heard. It is the age of artificial intelligence. So AI and AI powered applications are is where all the research is happening today. So I've listed a few there: autonomous vehicles, voice assistants, personal assistant, natural language processing. Most of the research that's going on today is around this area. We also have, what is, again, natural language processing, Internet of Things, and deep neural networks. If you do not understand these terms for now, that's all right. I just wanted to, kind of tell you where the current research is going on. So these are all the areas where much of the problems that are being solved in the data science area are around these. This is just for your reference. If you're just starting out in this field, it is kind of just to give you an overview of what are the kind of problems that you may encounter in the near future. So And of course, there are a couple of more things like autonomous machine learning and, of course, the cloud. Everything, as you all must have heard so far, everything's moving on to the cloud. So these are some of the areas in which current research is happening. This is just for your reference. You do not be intimidated by this. And there are ways to get to this, if not immediately. Okay, let's see what's going on in India. I just wanted to give you a brief, some statistics about where India figures in this scheme of things. So these statistics are from the Analytics India magazine. Again, they've come out with a report every year, and this is the 2020 statistics that I'm showing you here. These numbers may not mean much to you, but what I want to show here is that this revenue, the growth, the 19.5% growth in revenue that you're seeing, that is one of the highest within the IT industry. Okay, in the IT industry, analytics, though I've called it analytics here, if you're wondering why I've not called it data science, this report covers a whole lot of aspects of data science which they call as analytics. And the important thing to here is to see that there is this 19.5% growth year on year is stated to go as far as 35% by 2025. So I just want to give you an idea of the kind of opportunities that are coming up in India. Apart from that, if you look at this particular statistic that you're seeing next on the screen, 60% of the revenue is coming up from advanced analytics, predictive modeling, and data science. Okay, what I wanted to show here is that this industry is maturing and progressing in India. Okay, it's no longer these advanced analytics, predictive modeling, and data science are higher up the value chain in this field. So what I just wanted to show you is we have moved up from the outsourcing era to doing actual higher end of the value chain kind of problems, and that's a good sign for the industry in India. Just a few points about where the opportunities are. Bangalore has led the way with the largest share of revenue. If you compare all the cities in India, I think the NCR region is a close second. And the BFSI sector is the largest consumer of data science and analytics. And by BFSI, I mean the banking, financial services, and insurance sector. So this is just to give you an idea of where the opportunities lie. Okay, so if you are starting out in this field, couple of things for you to take back is that the industry is maturing, so you can expect to work in higher end of the value chain kind of problems. The BFSI sector, apart from the retail and healthcare, is another sector that is fast becoming a large consumer of analytics. So these are some of the places where opportunities exist. I also want to give you a little bit of demographics of the data science professionals in India. Just showing you what the experience level of professionals are and city-wise where the opportunities lie. We can move on. I can share this with you later. Again, based on education level, what's important here is again, postgraduates make up 27.3% of the professionals, followed by engineering undergraduates, and then non-engineering MBA. Just to give you an idea of the current state of professionals in India. And if you are looking at, or if you are confused about which path to take, I thought this may give you some idea. Again, I want to make a point here that do not be too worried about the educational background. There is a lot that you can do apart from the educational background as well. Okay, we can move ahead. One of the things that I wanted to mention here was about the participation of women in this space. Okay, it's right now stands at 27.8%. While this may seem low, what I think is that there is a huge opportunity. So if there are women students here or women youngsters who want to get into this field, I would look at that 27.8% as a huge opportunity. And if you look at the experience level also, for the entire analytics workforce, the average is about 7.4 years, while it is just 5.8 years for women. So what that means is that while there may be women who are entering this field, there are not enough women who stay on in this field. Okay, so these are the two statistics that I could get my hands on with respect to women, and I would look at it as a tremendous opportunity. And we'll come back to this towards the end. Let's go on and see now what do we do to get into this space. Okay. As data science professionals, we all love Venn diagrams. I'm sure you must have seen many such Venn diagrams. But this particular one, what I want to show you here is that, the first point, Parul, if you could just bring up the first point. Yeah. In my opinion, this is probably the most important thing to understand when you're trying to start off in this field. Data science is more about solving a problem and it's less about applying an algorithm. Okay, so if you look at data science, it lies at the intersection of mathematics and your mathematics and statistics, your computer science, and what we call as domain expertise. Okay, you need to have enough knowledge, or you need to build knowledge about the domain that you're working on. And it could be finance, it could be healthcare, it could be just about anything. But um, solving a problem is probably the first, it's a kind of a mindset that you have to cultivate. And most of us, when we start, especially if you're from a mathematics kind of background, we tend to go directly head on towards the algorithm without paying much attention to the problem at hand. So one of the things that I do want to point out is solving the problem is at the heart of data science. Okay. Yeah, can we move on, please? Yeah, domain knowledge is as important as technical skills, and this is something I cannot stress enough about. And apart from this, experience and practice is what takes you a long way and makes you from a beginner to an expert. Okay, so while we think of what skills we need to build, we also need to think about these three things. So you have the maths and stats component, you have a computing component, and you have a domain component. And all three of them are important. So, how do we go about building all three of these? Okay, and yeah, this is, again from the Anaconda report. What do data scientists do? Okay, if you look at it, there are diverse skills that are required. Okay, starting from data wrangling, data analysis, model creation, development, putting it into production, visualization. It's a life cycle, and there is a lot of roles and tasks. While you may, and typically a data science project is not something that you would do individually. You'll be part of a team, and where your role will fit into one of these. So while it is not expected that you be an expert in all of them, what I want you to see is um, it is a multidisciplinary field, and we need to build skills along all of these roles and tasks. So how do we go about doing that? Okay, so primarily, if you look at it, there are basic level skills, intermediate skills, and advanced skills. So if you look at that, don't worry too much about what's written within each of these, and the timeline also. Although the timeline is just something that is indicative, I wouldn't say that that timeline is not a strict timeline as such. So if you are a beginner and you're starting off in this field, how do we proceed? So if you look at the increasing competency, I would say start with the basic and the intermediate. And once you get there, you are almost certain that you can, the rest of it, the advanced competency is just a matter of practice. Okay, so let's go and see what are these skills that are needed in the basic and intermediate level. So I just want to spend a little time on how to build these basic and intermediate skills. So I've divided it into two parts basically. We have the tools and technologies, and then we have the technicals and soft skills. Okay, these are the two main things. So tools and technologies is one part, the technical skills and soft skills is the second big part. So in the tools and technologies, again, if you look at the first 2 points that I've mentioned in green, those are absolutely the must-have skills. The other two, the big data framework and the cloud technology, those are, it's more advanced and you can go up to it. For the basic and intermediate, the programming languages and the visualization tools, those if you start off with, those are absolute must-haves. Again, in the programming languages, it's highly debatable, Python or R. If you are somebody who is just starting off in this field and do not have much experience with programming, I would suggest Python, which is easier to learn. Visualization tools, of course, Tableau is not open source, but there is plenty of online help available. And Tableau and Power BI, while they are very good tools, you also can use the Python libraries and pick up skills in visualization. Okay. The more important thing, if you ask me, are the technical skills and the soft skills. And how do you go about building these? That's all of us know that these are important, but how do you build this? How do you build something like critical thinking and analytic skills? One of the things that I suggest to my students as well is pick a domain that you like, or pick a domain that you are passionate about. Let's say you like sports, for example. Okay, there's plenty of data available. Say, for example, you can pick up the IPL data set. Okay, there is the cricket IPL data set is available. Let's pick up that data set and start analyzing this data set. So one of the things that most people who start in this field do is they jump into the data set initially, and that can be a little confusing at times. Okay, one of the first things that you should do is start thinking about the questions that you want to answer, and that's the first step about critical thinking and analytic skills. Okay, I have this data set here with the IPL. I have maybe ever since it started off in 2008. What do I want to do with this data? What are the questions that I want to answer? So writing down the questions that you want to answer can help in this critical thinking, because you slowly start asking the questions. Okay, what do I want to get out of this data? Okay, so let's say, for example, is the IPL a youngsters game? Okay, is this a game that favors? So say, for example, you want to figure out what are the factors that go into the pricing of an IPL player. Is it the age? Is it their batting skills, bowling skills? So what are the different questions that come to mind? So writing down those questions is a good way of building what I call these analytical skills, and rather than straight away jumping into a data set. Okay, so it could be sports, it could be anything else. There are plenty of domains available, and I'll show you a few resources where you can get them. The the critical thinking and analytical skills are important because most of the time defining the problem that you want to solve is very key to actually doing the analysis. The business context and domain knowledge, again, this is something that comes with practice, with experience. And data science is a good way of exploring various business contexts. So if one of the things that I suggest to my students is try your hand at different kind of data sets. Pick a finance domain, pick a healthcare. The kind of analysis that you need to do for each of these domains are so different that you gain a lot of domain knowledge when you work on data sets pertaining to different kinds of domains. Of course, the core skills are the mathematics and statistics. This is where it's a fine line. How far into the mathematics do I go? How much of the mathematics do I need? So we can take those questions. I'm sure there are a lot of questions around that. I can take that separately, but this is, if you ask me, a very, very important skill, especially now with the libraries that are available. Most of us do not need to know the complete mathematics behind an algorithm. But if you do take the time to learn that, that's when it gives you a lot of, I would say, if you want to build something new, okay, that's when this comes in really useful. So the core skills, mathematics and statistics, are still important. And I will point you out to a few good resources where you can learn those skills. And communication skills, definitely one of the most sought after skills. Your analysis and your findings are only as good as how you communicate them. So communication skills are very important, and one of the best ways to build that is to keep writing. I know a lot of you write blogs, a lot of you write articles. That's a great way to build these communication skills. Or just practicing writing, practice when you finish your analysis, how do you communicate the analysis to the stakeholders? So one of the things that I recommend is write down who your stakeholders are and try to write down how you would communicate to each stakeholder differently. The way you communicate to each stakeholder has to be different, and that is something that you can build if you practice doing that. Okay, so this is a little bit about the core skills that you need to build. So I have a little roadmap here for those of you who may be just starting out on this. So 3 steps basically. The first step is programming fundamentals, and what I have written is pertaining to Python. So just the basics. How do you read data from different sources? How do you clean up data? How do you pre-process data? So these are what I call the programming fundamentals. That's absolutely step 1. Step 2 is what I called exploratory data analysis, where we are actually exploring our data, we visualizing our data, trying to find certain. So if you ask me, the kind of questions that you can answer here are what happened, or sometimes if you do the exploratory data analysis really well, you can even answer the why questions. Usually it is used to answer the what questions, but done well enough, you can even answer some why questions in this stage. But this is where a lot of your descriptive statistics comes into picture, and this is an important step. And step number 3 is the core algorithms. Again, here I have mentioned a few algorithms which are, if you can learn these few algorithms, In fact, I wouldn't even want to call it algorithms. You could call it as the kind of problems you want to solve. For example, prediction problems or classification problems, and each of those algorithms are just different ways of solving those kind of problems. So the details of all this, is probably we can take it up at a later stage, what these mean and where you can learn these. But I just wanted to give you an overview of three simple steps that you can do to get started with this field. Okay. Moving on to resources. Um, all of us know these resources, all of us are aware of these resources, but sometimes the problem is, where do I start? Okay, now data camp is something that I have found to be a very a very easy, or a very uh, helps you get started very easily. One of the things that I want to mention here, to if there are students listening in, most of us teachers get free access to data camp, and we can invite our students to take courses for free. So if you are students, one of the things you could do is go back to your professors and ask them about this, or you could get back to me and I can point you towards how to get these academic subscriptions where students get to learn for free. And in data camp there are, there are skill tracks and there are career tracks. So there is a nice roadmap which you can use, and I can help you with that later on. A lot of my students have been using this for the past 4 5 years, and they come back to me and tell me that it's been pretty useful to them. So data camp is definitely something I would recommend. Now, Kaggle is a place that I recommend to go to when you want to try out your, step one, step two, and step three. Kaggle has a lot of data sets available, and and also practice problems. So just like, in school days, you would go ahead and do the solved problems in a book. I use Kaggle as a substitute for solved problems. So pick up a problem in Kaggle, look at the way it has been approached. There are many wonderful notebooks there where you can go and just try to solve the ones that have already been solved, and then pick up data sets from there. For example, the IPL data set is there. There are plenty of data sets available for visualization. um, I have a list of few which I can probably share with the group at a later time. But so data camp for learning or picking up skills like programming skills mainly, and there are a lot of practice projects also in data camp. Kaggle for data sets and trying out problems, or looking at notebooks and picking and learning, going through those solved examples. Coursera, if you want to learn, some of the newer topics like neural networks, there are a few good courses in Coursera. Again, academic licenses are available, so if you are a student, do get in touch with me and I can help you with that. In terms of books, I've listed 3 books here. The first book, The Science of Data Driven Decision Making, that's a great book for somebody who's starting off. It is a postgraduate level book, but it's easy enough for anybody, even in an undergraduate, to follow that book. So though I've just listed the main points here, I can help you with specifics, but we could probably do it at a later time. So I will share these resources with you also. And so I was thinking a lot about, when Parul invited me to this community called Women in Coding and Data Science, I was thinking a lot about what can I say to women specifically. And this is what I came up with. So the first thing I would say is this landscape is filled with opportunities regardless of gender. I don't think there is anything specific that women need to do or girls who are starting off in this field need to do. I think the opportunities are the same. So I would like to believe that there is enough opportunities regardless of gender. But one of the things that data science really helps is that it is an interdisciplinary field. So it really benefits from diversity in thinking. So you have a range of opportunities starting from the coding skills to visualizations to storytelling. So it is all the more reason for women not to get intimidated by this field, and I'm sure there is a space for everyone here. So again, I couldn't think of anything that is really specific for women. Yeah, the field values a wide variety of skills ranging from deep technical skills to visualization and storytelling. So there is a opportunity for men and women alike. The challenges, if you ask me, are the same whether you're a man or woman. So I would say that again, the really only one thing that I would insist is that the girls are encouraged to get into science and technology courses. So that is the only thing that probably is a takeaway. If you, the background or the foundation for this field is definitely in the maths and statistics. So the technology education is something that we need more women to get into. So, and lastly, probably the one thing that I want to tell the women out there is to stay in the field. We do see a lot of girls getting into the field, but not enough of them staying in the field as you progress through life stages. So the key is to just stay in there, and it's not difficult, and also that there is a lot of support from groups such as WiCDS. So it is a very a welcoming field for the women, I would say. So that is my only message that I want to give to the women. What I wanted to show here is basically some research areas. Apart, a lot of times when we get into this field, we are usually seeing examples from the commerce field. We're seeing examples in commercials like the recommendation engines, the Amazon book recommendations, or advertisements or marketing. But there's much beyond. Data science has a lot of applications beyond that. As you may all have heard, in the life sciences, in clinical trials, there is a lot of scope. The data for social good, that is something that I would encourage more and more people to get into. And just want to leave you with this few words. These are exciting times to be a data scientist. And Parul, the last line. Data science can be used to address critical problems that impact society, and that's, I think, where all the major research that's going on today. So this is what I want to leave you with, and I will just take some of the questions that have come